If you are a radio amateur, or if you are a DX listener or radio enthusiast of some kind, this machine is something you do not want your neighbors to install. It has a CE mark on it, according to this. They guarantee it conforms with the CE rules, and it's the lawnmower robot, LMR24. SM6ENG has a neighbor who has one of these automatic lawn movers, and he made a couple of recordings, and I will play it with the Export SDR2 software. This is one of the files. Open this one and start playing. Now what you see here is a carrier approximately 1 every 8 kilohertz, because the lawn mower has a cable around the area within it should cut the grass, which carries 8 kilohertz, probably in the form of a square wave. Well, then it could be 4 kilohertz, and we see the odd harmonics, but it could be something else. It could be pulses at 8 kilohertz. Now that doesn't matter. What we see is the lawn mower only. This is daytime and long wave. The only signal that is stronger than the lawn mower is the one here. And we have the tone from the lawn mower. Something that maybe most people would not expect is this when I switch on the noise blanker here. You can see most of the interference goes away. What we see here is there is a carrier here, and it will now be keyed at 8 kilohertz, because the 8 kilohertz pulses that the blanker removes will remove the carrier periodically. So we get sidebands, 8 kilohertz on both sides, 16 kilohertz, and so forth. So if I switch off the blanker again and then go for a AM station here, and we cannot hear anything. I switch on the blanker and we cannot hear anything, but the interference moved a little bit. So now we can get it outside the pass band by lowering the bandwidth. It's very hard to hear anything because the signal is weak. I can try synchronous AM. And we can hear some music in the background. If I remove the blanker, then we get this interference back. I have to reduce the bandwidth, or maybe better, shift the frequency. Then I cannot use synchronous AM anymore. And now we can hear a little bit better. Not so good, but a little bit better. I will now play the very same recording in lead rod. and that is number 2, so I press 2 here and enter. And it looks familiar. Here you can see the pulses in the time domain. There is the second time function oscilloscope. So this is power, this is I, and this is Q. The system is not calibrated. I can enable the noise blanker by clicking here. That's the dumb blanker, and you can see it removes the pulses. But as you can see up here in the waterfall, it creates a lot of false signals. Now in Linrad, I can bring down this red bar here, and now you can see at this point, this, which is the strongest signals, gets red. Means it's routed outside the blanker. When it gets red, it is not keyed with the pulses, so the keying sidebands disappear. This signal here and this signal here, which were false signals, they are no longer present. So I can go to 225, where there is an AM station, a weak one, that I listened to before with the Sun SDR recording player. You can hear a little bit of the music. I can enable synchronous AM. In Linrad, that is coherent detection, like that. And I can try a little bit narrower bandwidth. What I did when bringing down the red bar is bringing down signals that survive noise blanker. The whole thing is rather complicated, and you have to read a lot of pages on my home site to get the details of this. I can bring down the blue bar. It works on the main spectrum, the blue thing you can see here. When I bring it down, I reach a point here when all the 8 kilohertz overtones become red. Means they are considered strong signals. Of course, then they are routed outside the blanker and not removed, and you see the big problem. And still, it doesn't make a big difference because the bandwidth now selected places the interference just outside the passband. If I increase the bandwidth, it's like this. So I bring up the blue bar. And it's a rather sensitive thing to set these controls right. And this is still the dumb noise blanker of Linrad. The system is not calibrated. In Linrad there is a quite different way of attacking this kind of problem. Enable AFC spur decode and 2. I make it 2 auto spur. Two. And then I have to set how many spurs do I want to be able to remove. It's 0 now, so I click here and select, let's say, 2000. That is plenty enough. Spur time constant 0.1 second, that means 10 Hertz bandwidth. I will make that, sorry, it is 5 times 0.1 second, that is 2 Hertz bandwidth. That might be reasonable for this lawn mower. And I go back here. And you can see up in this place here, up here, 53 spurs have been cancelled. I go to 225 where this interesting station is. And remove the noise blanker. And you can see in the second time functions all the pulses, but in the waterfall there seems to be no problem. Now we don't hear this station anymore because the spur removal has removed the carrier. There is no carrier on this station. I can go to the NDB signal we had up here. And you can see the 2 side bands, but there is no carrier. So this is not good for AM listening. I make X and parameters and spur. I make this 1. Not automatic, manual. And then I can again go to 225. And you can hear a little bit. And I have to center the frequency. And it seems I have now enabled the AFC. So I have to click here. And you can hear the spur from the lawnmower. I go into the main spectrum, place the mouse on the interferer, which is there, and press E. And of course I can remove all the spurs. Place the mouse close to one of them, press E. And again, press E. And there is no blanker now. And you don't see the pulses because the red is so low. I can bring it up. And you can see we have still the pulses, but on the frequencies of interest, the sine waves that they constitute, they have disappeared. You can only see each time the recording starts from the beginning again, every 6 seconds. There is a short time of interference. And I can of course now also enable synchronous detection. But if I do the mistake to go on the carrier, like that, and press E, then there is no carrier anymore. It's like the auto spur. So I press C to clear everything, and I get back the carrier, but I also get back the interference. So go back here and press E. So these problems can be removed in the time domain or in the frequency domain. In a smarter system, one could use information from both the time domain and the frequency domain to make this far more efficient and completely automatic. But since this kind of interference is not very frequent, normally this type of interference varies with time. The switching frequency changes and it may be modulated by 100 Hertz and there may be other problems. So I have not put any effort on doing this better, but it can surely be done. I'm now running without the second FFT, but I have the spur removal algorithm in manual mode. That's one here, and many spurs possible to remove. And here is the same recording, and I click on this weak signal. And the carrier is here, and the lawnmower, one of the overtones, is here. And it dominates, and it makes it difficult to hear anything. I could reduce the bandwidth. And then I hear something. But go back to a normal bandwidth. I can place the mouse on the interference and I press E. Some precision is required. And you can see the interference disappears and we can hear something. Now in Linrod there is one more alternative for fighting this kind of interference. I press X and P and then disable this spur removal thing by pressing 0 here and listen again. All the processing is linear. It means The notch filter can be placed anywhere in the signal path, anywhere in front of the AM detector, which is the last stage. So I want to get rid of the carrier here. I do that by applying a baseband notch. You can see it's 0 here. I change that to 1. Means notch number 1. And I place it at, let's say, minus 250. And then I make the width, let's say, 30. And you can see here is the notch. And I made it 250. It should be about maybe 600 to come on the right position. So I change that, minus 600. And it's close. I can change the filter bandwidth, which will move the notch in proportion. And now you can hear again the signal, because the notch removes this carrier from the output. We can still see it in the waterfall, but it's not routed to the loudspeaker anymore. And of course I can change the width, maybe 50, to make sure it is really well removed. And maybe minus 590 is more appropriate. And I can make the notch narrower, let's say 5. And that's not good enough, let's say 15. And at minus 585. Now the notch is very narrow, it will not affect the desired signal at all. In Linrad you can apply up to 9 notches within the baseband. It is manual, it could be automated, but I haven't really met any interest for that.